Alright, here we go, lesson number 2 of the medical physics, radiation health, how nuclear medicine, however you want to refer to it. So, as we know, radiation can damage tissue, living tissue. Right, so we know that. So we also know that sometimes with that living tissue, sometimes it's good tissue, and sometimes it's bad tissue in the form of a cancer, for example. So we can use it to try and kill that bad tissue, but we don't want to kill any good tissue, and in fact what we can end up doing is we cause too much damage, we can cause cancers to grow themselves. So this is where the idea of a radiation dose. So over time, people have found out that, well, there's radiation that we're exposed to just as a matter of course during the day, and so there's a radiation dose, a safe level that we need to keep it to. So the effects on the human body depends on two things. This is missing in your thing, the amount of the radiation and the other thing is the type of radiation. Alright, so, and depending on how much you're exposed to, so like for example in an X-ray, very useful information that we can get from an X-ray, but if you have too much X-rays, as people who originally discovered it were and didn't know what the problems would, you can damage the skin, well, and the blood and all sorts of stuff. So we need to limit the amount, use it when we need to, but keep the amount down. And then of course there's the type of radiation. So is it an X-ray, is it a gamma ray, is it an alpha particle, and so on. Alright, so depending on what that radiation is, it can cause some damage. So what's been come up with is a thing called absorbed dose. So the absorbed dose, and that's in the next missing word, is absorbed. Absorbed dose is the energy per kilogram of body mass. So from that we can get that, if you're a baby and don't have much in the way of body mass, then each kilogram is going to get a lot of energy. But if you're a grown adult, the same amount of energy per kilogram is much less. And so that's why when women are pregnant, we don't X-ray, because that fetus, being very small, is per kilogram going to absorb quite a lot of energy, and the potential of it being damaged is much higher. Alright, so in your notes then, and then the unit for absorbed dose is the gray. GY is the thing that's used for the gray. So 1 gray means 1 kilogram of body mass absorbs 1 joule of energy. Alright, so 1 gray then is 1 joule for every kilogram. So then we come, and this is missing space, we come up with the equation for absorbed dose. And that equals the energy absorbed over the mass. So the example you've got in your notes there is the child who's a mass of 25 kilograms, 25 kilograms, that's better, absorbs energy of 150 joule. Then the absorbed dose, and I'll just use AD, it would be 150 over 25, which is 6 gray. Alright, so that's the absorbed dose. Now, the absorbed dose is just about the energy. It doesn't take into account what's delivering that energy. So, does that energy come from an alpha particle? Does the energy come from a gamma ray? Does it from an X-ray? Alright, so to take into account the amount of damage caused by various different forms of radiation. Alright, so they take into account the damage of the different forms of radiation. There's a thing called the dose equivalent. So, dose equivalent. And so this dose equivalent takes into account the type. And so from that, then we're going to be able to make a comparison between the different radiations and compare to see, which potentially is going to cause more damage. So the dose equivalent is a thing from the absorbed dose times this thing called a quality factor. Alright, so the quality factor has to do with the type of radiation and what its potential for cause of damage is. Alright, so this is from your notes. So the quality factor is determined by the type of the radiation delivering the energy. So here we go, here some different types of energy radiation: X-rays, gamma rays, beta particles, neutrons that could be moving slow or fast, and alpha particles. And so there's what the approximate quality factors are. Now, don't take those as necessary definitive numbers. All right, there is some variation. There can be variation in the alpha particles, the neutrons, the beta particles. There can be some slight variations. All right, now quality factors kind of, in my mind, are a bit of a weird kind of term. That it's also called this other one, relative biological effectiveness. So in other words, what biological damage can it cause? So it's an RBE. Now I forgot to mention what the units are. So the units are sieverts. So 1 sievert causes the same amount of biological damage no matter what type of radiation. Alright, so remember that's taken into account what's delivering it, so whether it's one of these here, so this quality factor or RBE then creates a number that we can compare with everything. Alright, so let's have a look at an example. Alright, so the first part of this example, 60 kilo person absorbs 0.054 joule of energy. And remember, it's energy over the mass. And so it's 0.54, whoops, 0.054 over 60. And when you do that, you get 9 by 10 to the minus 4. And that's great for absorbed dose. Alright, so let's have a look at the next part of that question, or I should say the next few parts of that question. So part 2, it says what would be the dose equivalent if the energy was delivered by gamma rays. So the dose equivalent equals the absorbed dose, which is 9 by 10 to the minus 4, grey, times the quality factor, or the RBE, and for gamma rays in the table we're using 1. So that's simply 9 by 10 to the minus 4, and this is sieverts. And that, of course, if you want to do that, it's actually 0.9 millisievert, if we want to put it in that term there. Alright, either's fine. Now, if on the other hand it was delivered by alpha particles, then the dose equivalent would be 9 by 10 to the minus 4 times by the RBE, or the quality factor, which is 20. And so when we do that, you get 2 by 10 to the minus 2 sieverts, which is 20 millisieverts this time. So in comparison, a lot more than the alpha particles. And remember, alpha particles, not alpha particles, then the gamma rays. And remember, the gamma rays can penetrate a lot, so the gamma rays possibly pass through your body, whereas the alpha particles will most definitely be stopped. Alright, so which causes more damage? Well, the 20 millisieverts is much higher than 0.9, so the alpha particles will. And as a matter of aside, about 20 times. Alright. Now, as I kind of touched on before, there is radiation around us all the time. This comes from outer space, cosmic radiation, and infrared from the sun, and all that sort of thing. So there is radiation around us all the time. And, you know, rocks in the ground and stuff like that. So, and that sort of stuff is what we would refer to as background radiation. So background radiation is radiation that occurs naturally in the environment. And it says there cosmic rays and the rocks are the main contributors. Alright, so all rocks around us will have carbon-14, a certain amount, which is radioactive. Alright, but again, as I said, it's nothing for us to worry about, because we're quite adapted to dealing with that minor. It's only when we get higher radiation. And then when we get the higher radiation, then we have the effects on our body. And so the big thing is, because these things ionise, so it could ionise one of the molecules in the cell, forming an ion. Now, in particular, in the DNA, because ions are reactive. Ions have a charge, remember? Ions are charged. So ions are charged, and so if they're charged, then they're quite reactive and can react with other stuff in your cell and cause it to die, or, as it says there, reduce at an abnormally rapid rate. But the problem is, it's not only that it's abnormally rapid rate, but it's not doing the job that it's supposed to do. And so when that happens, it's when we have a cancerous tumour that may form. All right, so effects of ionisation, this is the last bit. So there's the so-called somatic, and all somatic means is human bodies. So it's somatic effects are effects on the human body. And they tend to be short-term, and then there's long-term genetic effects. So the long-term genetic effects, if the reproductive cells, the eggs and the sperm, if they get damaged, then they could pass that damage on to subsequent children, grandchildren, etc. So this is in your notes here. This table is in your cell. Is in your notes. This table is in your notes. Right. Okay. So these effects, the somatic effects, these are the effects on the human body. So of course, they would occur when the body cells get damaged. All right, and so depending on the exposure, these are the kind of things that can happen. So low exposure, affects your blood cell levels. You can get, nauseous and stuff like that. Medium, your increased likelihood of death. High, and then extreme. It's extreme. Your body just doesn't cope at all, and does all sorts of not very nice things. All right, so we need to keep this radiation overexposure. We need to keep it down. So they're the kind of body effects, the somatic effects. When I said short term before, some of them, if you have too high a radiation dose, they're not really short term; they're actually terminal. So we need to be aware of how much dose that we have. And, there's levels that are set by governments as to how much you're allowed to be exposed to. All right, so the last was the genetic effects. So, as I said, can affect the reproductive organs. And so if we do that, then could be passed, that damage in that DNA in particular, can be passed on to the children and grandchildren, and we know these as mutations, and certainly we are well aware of that from things like the war when Hiroshima and Nagasaki had the bombs dropped on them. All right, now, or at least last bit I've already mentioned when I talked about the radiation dose, and that's about developing fetus, very sensitive, so pregnant women aren't generally given X-rays. But, we have other techniques, ultrasound, for example. We have that we can use. All right, so that's it for the radiation dose and the effects. So if there's anything in there you're not sure about, make sure you ask. And then there's some questions. And of course, as always, there's a few interesting videos on the website.